What can we put in the place of tangent squared theta plus 1? Mm-hmm. And what's the square root of a squared secant squared?
A secant theta.
All right. Finish exploration 4 the same way. See what square root of u squared minus a squared becomes if we put a secant theta in place of u. What can you put in place of secant squared theta minus 1? Mm-hmm. And what's the square root of a squared tangent squared theta? All right. So what trigonometric substitution is about is changing expressions that originally don't involve trigonometry at all, but we don't have any other way to evaluate them. Taking those expressions that involve square root of u squared minus a squared, or square root of a squared minus u squared, or square root of a squared plus u squared, and turning it into something with trigonometry in it, but something that we can integrate because we got good at that in 8.3. We got good at integrating trigonometric expressions. All right, so if you give me some expression with a radical in it, the first thing that I've learned to check is it one of the 3 inverse trigonometric functions that I already have memorized and keep forgetting and keep rememorizing and keep forgetting? But I'm going to see if it fits the pattern of square root of a squared minus u squared, or a squared plus u squared, or u times the square root of u squared minus a squared. If it's one of those 3, I already know how to integrate it. But if it isn't one of those 3, I'm going to use these 3 triangles to integrate something I couldn't have integrated before. All right. The thing that was most difficult to me in doing this section was there are 3 variables. There are x's, there are u's, and there are thetas, and they were all getting mixed up in my mind. I had to come up with a format. I'm going to use this format for all of these problems because the variables are starting to really mess with my head. So that's why I made you this, that's why I made you this other handout to show you the steps that I went through in integrating. This is number 26 in the book. Number 26 is the indefinite integral of square root of 25x squared plus 4 over x to the 4th dx. The first thing I would look to see is that one of my inverse trig functions? It looks like a, well, all my inverse trig functions, arcsine and arcsec, have the radical on the bottom, and this doesn't have the radical on the bottom, so it's not one of those 3. All right, when I've identified it's not one of those 3, what I have learned to be the best way for me is to first identify what the u is and what the a is. U is a function of x. It's the x term that is squared and gives you 25x squared. So what is u? 5x. And a is the square root of the constant, which is
2.
Yeah, square root of the 4 is 2. All right. Which one of these 3 triangles and I draw those 3 triangles at the top of my paper, I will draw, I'm thinking about making that one problem on the test where you just label those 3 triangles so you have them for reference. Which one of these trig substitutions involves something that looks like this, a u squared plus an a squared? Yeah, it's tangent that has a u squared plus an a squared. So the substitution that I'm going to use is let u be a tangent theta, where a is 2. So u is 2 tangent theta. In the a part, I have u is 5x. In the b part, I have u is 2 tangent theta. Then 5x has to be 2 tangent theta. And I can solve that for x. If I set 5x equal to 2 tangent theta, then x has to be 2/5 tangent theta. And if that's what x is, what is dx?
2/5 secant squared.
Mm-hmm. All right. Seems like.
D theta.
Oh, yes, thank you, d theta. Gotta have that. Now I want to find a trig expression equivalent to the radical portion of the integrand. The radical part of the integrand is the square root of 25x squared plus 4. And if I let x be this 2/5 tangent theta, then it should simplify to some much easier to work with trigonometric expression. I'm just putting 2/5 tangent theta in the place of x. It's still squared, and I still have my plus 4. Simplify that just like we did the d parts of explorations 2, 3, and 4. See what that cleans up to be. What does that clean up to be? And then I take the square root of that, and it's just 2 secant theta. That just cleans up to be 2 secant theta. Now, I could memorize what's in this box if I had brain space left for it. What's left in that box is when you see the square root of a squared plus u squared, just memorize, use u plus a tangent theta. I don't want to memorize that. I'd rather do the triangle. That's easier for me. And I could also memorize when I have that, then the radical expression would be a secant theta, because that's what we just came up with. 2 secant theta is this guy, but I don't want to memorize that. So I've gotten where I can do this step in my head pretty quickly. I don't have to write down all these middle steps, and I have a trigonometric expression that I can put in place of the radical expression in the original integrand. All right, the original integrand was this. What can I put in the place of square root of 25x squared plus 4? 2 secant theta. What can I put in the place of x to the 4th?
2/5 tangent theta.
Mm-hmm. And don't forget that you also have to put something in place of dx. What can you put in place of dx?
2/5 secant squared theta.
Yep, there, right here. 2/5 secant squared theta d theta. Does it look like I've made the problem easier? No. Looks like I made the problem much harder. But this cleans up into something that turns out to be pretty simple, where I was just stuck on that. There was nothing that I knew before today that would have allowed me to integrate that. Let's see what this cleans up to. If I write that as a single fraction, I'm going to have a secant cubed theta in the numerator. And I'm going to have a 2/5 in the numerator. And I'm going to have a 2/5 to the 4th in the denominator and a tangent to the 4th in the denominator. And then d theta. I'm going to make sure I haven't lost anything. Here's my 2 secant theta. Here's my 2/5. My secant squared times secant is secant cubed. I raise that guy to the 4th and that guy to the 4th, and all that's left is d theta. So far, so good. I can say this 2/5 takes out one of those 2/5 and just leaves me 2/5 cubed in the denominator. And I also know that I can bring the constant out front. So what's dividing by 2/5 cubed the same as? Multiplying by 5/2 cubed. 5/2 cubed is 125 over 8 times 2 is 125 over 4. Yep. 125 over 4. And then what could I do to clean up that secant cube over tangent to the 4th? If William were here, he would just do it all in his head and spit it out. But what about me?
Secant squared.
You know, that absolutely might work, Sam. I don't doubt that that would work at all. But my thought is, if I change them both to sine and cosine, a whole lot of stuff is going to cancel, I think. All right, so either way, we could try it both ways. But I'm thinking if I write that secant cubed as 1 over cosine cubed, and dividing by tangent is the same as multiplying by cotangent to the 4th, would be cosine to the 4th over sine to the 4th. And that's 125 over 4 times the indefinite integral of, what does that clean up to?
2 secant theta over sine.
All right. We got it down to something that could have been a problem in 8.3. We learned how to integrate trig expressions like that in 8.3. Got any ideas?
What sign do you
I didn't do a formal change of variables, but I said, this looks like ugly to the -4. And this is derivative of ugly right beside it. And if I think of it that way, then I can use the power rule. So I'm thinking of it as sine theta to the -4 times the derivative of the ugly right beside it. And then what does the power rule tell me to do?
add one to the exponent of it?
Add 1 to the exponent, that would give me sine theta to the -3, divide by -3, and this is -125/12. Instead of sine to the -3, I could write it 1 over sine cubed. I could just put the sine cubed in the denominator. And that's perfectly fine, 100% okay. Or I could write that as -125/12 times cosecant cubed theta. Either one of those would be okay. Ooh, Aaron.
Let's see.
All right. Actually, I've already done that step. I got my lines mixed up. But I've already integrated. That's what I have for the integral of negative, or the integral of this guy in the F part. The thing is, the original problem didn't have thetas in it. So my answer can't have thetas in it. How am I going to fix that? Well, maybe either one of these,
You use a triangle.
I can use my triangle to find out what sine theta is. I don't know what theta is, but I can figure out what sine theta is by using my triangle. Let's see, in that triangle, I used tangent right here. I used u equals 2 tangent theta. That means tangent theta is u over 2. I'm going to label this triangle with some angle theta and label the sides in such a way that tangent theta is u over 2. Which sides does that give me? Opposite is u, adjacent is 2, hypotenuse is square root of u squared plus 4. So without even knowing what theta is in degrees or radians, I'm not going to know what theta is, but I can tell you what sine theta is. What's sine theta? Mm-hmm. Let me use this one. Let me say sine theta is this over that, so cosecant theta is this over that. Square root of u squared plus 4 over u, and that's supposed to be cubed. At least we don't have thetas in it anymore. But our original problem didn't have u's in it either. Our original problem had x's in it. So what can we put back in the place of u? 5x. I'm gonna go ahead and say 5x times 5x is 25x squared. And then clean that up a tiny bit.
Why is it over 2?
I was just wondering that myself. I just noticed, why is that over 2? Let me see. That was just,
Is that what you?
let me think. I was looking for something to put in place of cosecant. Cosecant, okay. I don't know. Cosecant would be this guy over u, not that guy over 2. And then in place of that u, I just put 5x. So how do you think that final answer will be written? Hey, I have a negative 125 divided by a 5 cubed. 5 cubed is 125. I think that just leaves negative 1 in the numerator. And then I could write square root of 25 x squared plus 4 to the third as what?
25x squared is 4.
Yep. And what would be left in the denominator? Yep, that 12. And this x cubed. Plus a constant. All right. That was after I figured out the steps. It was still a lot of work. These are a lot of work. That's why you don't have 30 of them in homework. But these are the steps that helped me keep straight the x, the u, and the theta. And any steps you can do in your head and skip, more power to you. I'm not going to skip steps in my notes. We'll pretend that I could, but really I'm not sure that I could. All right, pass that back to Major, please.
So that was for when you're finding the value of x and you're not given the value of x.
We're not given what substitution to use, and we have to use those 3 triangles to figure out which substitution to use. So I'm going to keep those 3 triangles right at the top of my notes. And yesterday I was working on the practice test. Oh, by the way, I have put a tentative practice test on momentum on the back of it. You know how for test 1 I had things to know for test 1? I'm still working on the back of it, but our toolbox, which in test 1 I think just had 3 bullet points, our toolbox now has 8 bullet points. So you can go ahead and print it. I'm not certain that it won't change some, just as I think of more things to add, put in my toolbox. All right, those 3 triangles, definitely in my toolbox. Let's see what we can do with number 30. Doesn't even have a radical in it. Why is it in this section? Well, we do know what something to 3/2 means. It's the square root of something cubed. And that looks like some u squared plus a squared to me if I let u be what? And a be what? Yeah, it's got to be the thing you squared to get 5. So it's got to be the square root of 5. All right. Looking at my triangles, which one involves the square root of a u squared plus an a squared? This one. So u equals a is square root of 5 tangent theta. And on this one, I have u equals x and u equals this. So x equals square root of 5 tangent theta. That one we didn't have to solve for x. I probably could have skipped that step. But on number 26, we didn't have x equals this. We had 2x equals this, and we had to solve for x. If that is x, then what's dx?
Square root of 5 secant squared theta d theta.
Yep. And I've learned that the other thing that's easier for me to do before I go back to the original problem is find that equivalent expression for square root of x squared plus 5. If I have x is square root of 5 tangent theta, then what will this simplify to? You can get where you can do that pretty fast. I don't need to write down any more middle steps right here. If I squared that, I'd have 5 tangent squared theta. I'd factor out of 5, and what would I be left with in parentheses if I factored out of 5? Tangent squared plus 1, also known as secant squared. So I'd have square root of 5 secant squared theta, better known as square root of 5 secant theta. All right. So going back to this original problem now, or the little bit of rewriting that I did, how could I write that integrand in terms of all this stuff over here on the right? What can I put in place of square root of x squared plus 5?
Square root of 5 secant squared.
All right, and that is cubed. Oh, not secant. You may not have said secant squared. I was writing secant squared. That's not right. That radical expression is just square root of 5 secant theta, and it's cubed. And when I wasn't being careful, I would just write down d theta instead of what dx actually is. Dx actually is this guy. All right, let's clean up the constants first. What is square root of 5 divided by square root of 5 cubed? If one of those, well, let's see. I can put in a middle step if I need it.
Square root of 5 squared.
Yeah. That's cubed. And then this is cubed. This square root of 5 takes out one of these square root of 5s. And what's square root of 5 squared? Just 5, and so what can I bring out front? 1/5. And what about when I clean up my secants? One over secant theta d theta. All right. So far, so good. How do I integrate 1 over secant theta d theta? Mm-hmm. Is that something I know, or does it take some magic? It's something I know. I don't remember where I learned it. I think it was 8.1. But the antiderivative of natural log of cos, oh, I was getting the answer in there too fast. The antiderivative of cosine theta is what?
It would just be sine. That's just fine.
Yes. What am I thinking? What am I thinking? Natural log. I'm thinking secant and tangent, when you integrate them, go into natural logs. But cosine doesn't. Jeez.
Everything except sine and cosine goes into natural logs.
Yes, that's right. So this is 1/5 sine theta plus a constant, and I've really become OCD with this. I've been OCD my whole life. But does that need a negative if you take the derivative of sine? No, it doesn't need a negative because the derivative of sine is cosine. We don't need a negative there. So 1/5 sine theta plus a constant. Now we've got to change it from sine theta to something with u's in it, and then from something with u's in it to something with x's in it. Where do I get something I can put in place of sine theta? A triangle. We did the substitution. Tangent theta is u over square root of 5. So opposite of theta is u. Adjacent to theta is square root of 5. And then the hypotenuse, if we need it, is 5 plus u squared. And so what can I put in place of sine theta? Opposite over hypotenuse. And then what can I put in place of u? No, I want something with x's now. Yeah, I'm through with u's. I'm ready to change this back to x's. The u is just x. And what about the square root of 5 plus u squared? Square root of 5 plus x squared. Yep. All right. Kind of ugly. What I've started doing, what helps me, and I didn't necessarily do it right here, but at home, I've started folding my paper in half, doing all my substitutions and anything that's not integration over here on the right-hand side of my paper, and then actually keeping the integration on the left-hand side of my paper. It's the way I organize it. All right, we probably only have time for one more, and I've had more than one circle, so let me see. Do I want 34, 36? Ooh, 36 looks bad. 34. Let's see. Yeah, 34 doesn't look drastically different. 36, I think we need to do, and then maybe I'll say something about 46, even though we won't have time to do it. Let's do 36. It looks so innocent. Just x sine x dx. Why is that even in this section? It doesn't have anything to do with radicals. If it was just mixed in with 100 other problems, I'd look at it, and the first thing I would notice is, hey, that's a product. That's x times something. That's my unproduct rule. Integration by parts is how I unproduct. And what's that acronym, if I'm going to use integration by parts, what's that acronym I use to LIATE? I'm not sure how to pronounce it, but I'm trying to pick my U, and I think there's no logarithms. That I is for inverse trig, and there is inverse trig. So let's let U be the arcsine of x. And of course, if that's U, then du, I still have to look up that formula. I will sit down the night before the test and memorize it, and as soon as you give me the test, I will write it at the top of the test real quickly, because I can tell you that's not going to stick in my brain. But because I looked it up, I have it 1 over square root of 1 minus x squared dx. Oh, there's where the radicals are going to come in. And if that's U, then what does dv have to be? Everything that's not part of U is part of dv. That's x dx. And so what's v? The integral of that is 1/2 x squared. All right. We have all the parts that we need to do integration by parts. It starts with what? U times v is 1/2 x squared arcsine x. That's uv, and then what?
Minus the indefinite interval of v du.
Yep. That's sexually transmitted disease again. VDU. I can't say VDU without thinking. What am I thinking?
BD.
VD. Yeah, that's what I'm thinking. 1/2 x squared times 1 over square root of 1 minus x squared dx. All right, now I see why it's in this section. That square root of 1 minus x squared. Let me clean this up just a tiny bit. I'm going to bring the 1/2 out in front of the integral and just say this is x squared over square root of 1 minus x squared dx. And then it's probably going to be time for trig substitution. All right. This is my work for integration by parts. And then here's my work for trig substitution. What's U? Entirely different from this U. We've moved on now. We got a different U for trig substitution. U is x, and A is 1. And then look at my triangles and say, where are my triangles? Which one of those involves this looks like a squared minus u squared. Yep, that's sine. So u equals a sine theta. And if u equals x and u equals sine theta, then my substitution is going to be x equals sine theta. And if x equals sine theta, what is dx? Cosine theta d theta. All right, only one other thing I have to do over here to the side before I go back to my integral. I want to find a trigonometric expression for the radical part, the square root of 1 minus x squared. That's the square root of 1 minus sine squared, which is square root of cosine squared, which is just cosine theta. So now I can go back to the left-hand side of my paper. And you know I don't like taking pieces of the problem apart. Even if it means I have to rewrite this 50 times, I'm not going to lose it. If I lose it once, I might lose it for good. So I'm just going to keep up with 1/2 arc squared, or x squared, arc sine x minus 1/2. And then what can I put in place of x squared?
Sine squared.
Yep, if x equals sine theta, then x squared is sine squared theta. And what can I put in place of square root of 1 minus x squared? Over here, that's just cosine theta. And don't forget you have to make a substitution for dx as well. What's dx? Cosine theta d theta. Mm-hmm. That integral cleans up to be just sine squared theta d theta. In 8.3, how did we learn to deal with even powers of sine and cosine?
It's 1 minus cosine 2x over 2.
And I usually bring the 1/2 out front. That's the 1/2 that was already there. Here's the 1/2 I'm bringing out front. And I'm going to write right here what that substitution is, just in case you've forgotten it. I finally have it memorized now. Sine squared theta is 1/2 1 minus cosine 2 theta. That's the substitution I'm using. And I brought the 1/2 out in front of the integral. And 1 minus cosine theta d theta is my integrand.
Would it be cosine 2 theta?
Yes, thank you. All right. Are we ready to integrate this? Can we just say the antiderivative of 1 would be what? Theta, because we're integrating with respect to theta. What about the indefinite integral of negative cosine 2 theta? To integrate cosine 2 theta, what would have to be part of the integrand? I'd have to have a 2d theta. I don't have a 2d theta. If I wanted to put one there, I'd have to put another half out in front of that term only. And the antiderivative of cosine 2 theta would be, I'd just put sine 2 theta, and then I would check my SIGN. If, oops, 2 theta. If I integrate sine 2 theta, I'd get cosine 2 theta times 2, and that 2 times this 1/2 would give me back that 1 that's right there. And my SIGN is correct. Look, I have half of the problem in terms of x and half the problem in terms of theta. I'm gonna have to clean that up. I distributed that -1/4. All right. What can I put in place of this theta? Look back at the right-hand side of my paper and tell me what I can put in place of theta. Yeah, dang it. Over here, if x equals sine theta, then theta is arcsine of x. What can I put in place of sine of 2 theta? None of the substitution stuff that I have has a 2 theta in it. I don't know anything about 2 theta. I only know stuff about 1 theta.
Can you multiply what theta is by 2?
Take the arcsine of sine theta, multiply theta by 2, and then multiply arcsine x by 1/2.
Or, because I didn't get that, and you may be right, but I didn't get that. I don't know if it was legal or not. Just mention. There's only one of my double angle formulas that I use often enough to actually have it memorized. You have one of your double angle formulas memorized? Sine of 2 theta?
1 plus cosine theta.
That's one of the double angle formulas, more like one of the double angle formulas for cosine. Here's the one that I have memorized.
Cosine.
Yes. Yes. Sine 2 theta equals 2 sine theta cosine theta. And so that's what I'm putting in place of that sine 2 theta. And almost didn't have room for it. Better zoom back in so you can see. I'm so close. What can I put in place of sine theta?
X.
X. Do I have what I can put in place of cosine theta? Yes. Didn't have to have a triangle for this one. Sine is just x, and cosine is square root of 1 minus x squared. That is 100% okay. It took me a minute to figure out why they had this in the back of the book. And on the test, I don't care if you get this step or not, but once they cleared out the brackets, they factored out an arc sign. Actually, they factored out a 1/2 arc sign, and it does give you that. But don't worry about that. The only thing that I was going to do 46 was to remind you that when you do a formal change of variables, which is the easiest thing to do on this one, when you do a formal change of variables on a definite integral, you have to change the limits of integration too. All right, you can look at one like that in the solutions manual if you need to. All right, the homework is finish up 8.4, except for I've locked all those problems off the end. These are long enough that if you just do 21 to 35, that's plenty good enough. All right, SMHS, go home, go back to bed. Go to bed with all your friends. No, don't do that. Go home and go to bed by yourself.
Yeah. On Friday.